So it would be like this.
I'm proud of your
Okay? You get the idea? Alright, now I'm going to try to do this with a problem to explain it. So I just made these numbers up. I said outside temperatures are recorded each hour on a day in spring. What is the average temperature for the day? Alright, how would you do that? What's the average temperature for the day? This is not a trick question.
Yeah. 25.
So it would be 35 plus 34 plus ... 37. Do you see where I went?
Yeah.
All divided by how many? 24.
Isn't it 25?
What about zero?
The zero
Oh
counts.
shoot, I didn't want that. Okay.
Wait, what?
Alright.
Oh.
I don't want that. Okay, we just get rid of it. Okay, so 24. Does this make
What?
sense?
No, don't. Why did you? It's snowing.
Because I want 24.
It's
For
snowing.
now. It's just
Are
easy.
you kidding me? We have a better.
Okay, oh, I forgot to so here it is.
I keep forgetting.
Okay, I'll put this down.
Global climate change.
Okay.
Whatever.
Because the first 35 should be there.
Now, I don't know if you guys can think in terms of this calculus like this, but for better accuracy, what could we do? Why is that not accurate anyway?
Because you're missing the fluctuation between the hours.
That's exactly it. You're missing the fluctuation in between the hours on the temperature. Like from 1 to 2, it might not have stayed 34 the whole time. It might have gone up and down. It might do that between all of these hours. Oh. So how could we do better for better accuracy? What could we do?
Trapezoid method.
Good guess.
Good plan, Aaron.
Just throw an idea out. I won't make fun of you like I did Jenna, I swear.
He says that now, but wait till you say something stupid.
Come on, now think about it. We took 24 temperatures, add them all up and divide it by 24. Take 48 temperatures. Exactly. Why don't we do 48 temperatures? And divide by increase n. So what are we going to keep doing? We're going to look at as the n goes to
Oh God, no, limit. I hate those things.
here's the one to
make a difference if we still have all these same numbers.
what if we took this? Now, I'm not going to say what temperature all these things are. I'm just going to say like this. Like this, increase n. So what are we going to look at basically? The limit. The limit. So we're looking at kind of a limit here. As the number of temperatures increases. The more temperatures you have, the better the accuracy. So that's exactly what I'm going to try to prove to you now here with this stuff here. Now I'm going to get some space and I'll get this going. Okay. Okay. So the average temperature equals that. Now I'm going to say it's about that because that's not precise. That's about that. So I'm going to try to come up with the exact one, and here's what I'm going to do. Now I got to talk about n for a second. And now, how do I come up with n? Sarah, listen to this, okay? Okay, now I need to change this to, because I'm trying to get this to work with the formula. So I'm going to go up here and describe n up here. Let's see if I say this right. Okay, here we go. The number of rectangles is equal to, now let's see if this makes sense. Your last temperature minus your first temperature divided by the change in temp time. Did I say that right? And that would be equal to, that's not, I said that wrong. Hold on, let me say this better. Your last time minus your initial time, in that case we had 1. And so that'll tell us the number of temperatures. So what was our last time? 24. What was our first one? 1. And then the change in time. when we had 24, it was 1. That's not what I wanted. Maybe I want that 0 in there. Take that out. It equals 24. That's the number of. Okay, just hold on a second to get this to work. I changed it to T.
Because the increments that T's counting by.
It's like, it's the fence post.
I did.
Hey, will you guys listen, okay? I'm getting a little sidetracked here and I'm having trouble, so I need some quiet. This is the reason I changed it back to 0, is because they call this the fence post question. If you have a fence that is made up of fence posts like this, okay, and I have these, there's 4 fence posts, and how many slots in between? 3. So that's the reason I'm gonna start with 0 after all. So, and getting back to this, this is a little formula that you can use to figure out what the number is. So I'm going back to this one, and I'm gonna put in here like this. Capital T is the temperature, little t is the time. I'm gonna call the last time instead of T, so then I'm gonna call it B. And the first time I'm going to call it A, and then I'm going to divide it by the change in T. Because I'm getting used to the B and the A that we're used to.
Wait, little t is time, and then big T is temperature?
This is temperature. Okay. And then the little t is time. Okay. Now I got to work with this thing, and basically I'm going to do what Brooke was saying, is just increase the number of rectangles. We're going to increase this. And as it increases, the average temperature is going to be closer and closer. Okay, so now I got to do some algebraic gymnastics here, and here's what I'm to get to there. All right, so I'm going to take this. If you have this divided by a fraction, it's the same thing as multiplying by the reciprocal. And I'm going to put that in front, and I'm going to have this. Are you guys okay so far? Okay. I guess I better put this in parentheses, that would be better. You guys okay with me?
Mm-hmm.
Okay, so now what I'm going to do is I'm going to distribute that change in T to each one of those. So it's going to say this. I'm going to make sure I say this right. I'm going to do T sub 1, change in T, plus T sub 2, change in T, T sub 3, change in T, plus dot dot dot, T sub n, change in T. Everybody okay algebraically? Okay, so now I'm going to rewrite this. I'm going to put this as 1 over b minus a. Now instead of writing it out all like that, as all the sum of all those things, I think I'll write it as a notation like this. And I'm going to say that the t is going to be an I here, because that counts how many temperatures we have. And then I'll put the change in T right here. And I is going to go from 1 to however many I want. Okay so far? Okay, so now, if I want to find the exact average temperature, what am I going to do?
Take the limit of that.
Yes, that's it. Take the limit of all this. So I'm going to do this.